Our next improper integral is here, the integral from 0 to 25 of 1 over square root of x. I'm going to rewrite this without the denominator. This is from 0 to 25. I'm going to write this as x to the negative 1/2. And it's important to notice, at x equals 0, there is a vertical asymptote. If the function, if the denominator is equal to 0, causing the function to be undefined, if the denominator is equal to 0, at one or the other of these limit values, the upper or lower limits of integration, then there's a vertical asymptote at that limit of integration. In this case, there's a vertical asymptote at 0. Vertical asymptote at 0 means this is an improper integral. So I'm going to rewrite this as the limit. And is it clear what variable I'm going to use? I will always use a for the lower limit of integration. And you're approaching 0. The question is, the lower limit of integration, you are always approaching from the right through values greater than 0. And then I can rewrite this integral using the don't know yet and the 25. This is x to the negative 1/2. And we're off to the races. That setup needs to become automatic for you. There can be no hesitation, no questioning about what goes where, translating from the improper integral into the limit statement. Now, the rest of this is, there's plenty to do yet. We're not done, but getting from here to here, if you don't get to this point correctly, then really whatever comes after this is not going to be accurate. So what do we do? Evaluate the antiderivative as usual. Substitute upper value minus lower value, right? And then substitute the limit value in for that limit of integration, and we're off to the races. So this is the limit as a goes to 0 from the right. And I need the antiderivative. I need the antiderivative of x to the negative 1/2. What's the antiderivative? That's x to the positive 1/2 divide by 1/2. And I will rewrite that as 2 times x to the 1/2. So this is equal to the limit as a approaches 0 from the right. And what do we have? This is 2 x to the 1/2. This is evaluated from a to 25. And as always, I'm going to bring this down here. This is the limit. A goes to 0 from the right. As always, it's expression minus expression. Evaluate at the top minus evaluate at the bottom. Evaluate at the top. This is 2 times 25 to the 1/2. 1/2 power means square root. Minus, evaluate at the bottom. 2 times a to the 1/2 power. 1/2 power means square root. So now we can actually evaluate, substitute. We've substituted the upper and lower limits of integration. Now evaluate the limit. To evaluate the limit, just substitute 0 in for all the a's. So this is 2 times 25 to the 1/2 minus 2 times 0 to the 1/2. Well, I know that. That's 25 to the 1/2. That's 5. So this is 2 times 5 minus 2 times 0. That's 10. So translate over, and then just that's your focus. That needs to be your focus. Don't want to lose this focus. You need your focus. Evaluate the antiderivative, and then substitute top limit of integration minus bottom limit of integration. Simplify that if you want to, but then substitute in the value for a's. Evaluate that limit, and then all we have is constant from here on out. So that's the procedure. We can work through a couple examples here, but that's the basic procedure. And I think if you practice this 2 or 3 times, you'll have it.